Nonmetals engage in covalent bonding to obtain an octet of electrons. Group 4A nonmetals have 4 valence electrons and need to share 4 electrons from other atoms. Group 5A nonmetals have 5 valence electrons and need to share 3 electrons from other atoms. Group 6A nonmetals have 6 valence electrons and need to share 2 electrons from other atoms. And group 7A, with 7 valence electrons, needs to share 1 electron to obtain an octet. Although every member of a group has the same number of valence electrons, I'm focused on the nonmetals because they are the elements that covalently bond. Nonmetal atoms tend to form the same number of bonds. Group 4A atoms form 4 bonds, and carbon always forms 4 bonds. Group 5A atoms form 3 bonds, Group 6A atoms form 2 bonds, and Group 7A atoms form 1 bond. Table 3.4 of the textbook summarizes these bond trends and also draws the number of lone pairs that each atom from a given group will have. Hydrogen always forms 1 single bond and never has a lone pair of electrons. Carbon always has 4 bonds. Carbon can form 4 single bonds, 2 single bonds and 1 double bond, or 2 double bonds, or 1 single bond and 1 triple bond. Carbon never has a lone pair in Lewis dot structures. Nitrogen forms 3 bonds and has 1 lone pair. Nitrogen typically has 3 single bonds, but it can have 1 double bond and a single bond, as well as 1 triple bond. Oxygen always has 2 lone pairs and 2 bonds. Oxygen can have 2 single bonds or 1 double bond. Sulfur, on the other hand, tends to engage only in single bonds. Halogens tend to form a single bond and have 3 lone pairs of electrons. Notice that for each family, an octet of electrons is obtained through bonding and lone pair electrons. These bonding and lone pair patterns will help you draw and evaluate Lewis dot structure.